Hello, grade 10s. We're starting a new unit today. It's Unit 5, Quadratics in Vertex Form. The first thing I want to do is just give you a couple of terms for the unit, and pretty much everything that I have here will be in the handout that I posted. Okay, so let's start with some terms. Again, in class we would do a whole thing where you try and figure out what they are, etc., but it doesn't really work here. So the first definition is a coefficient that can be changed in a relation, and that is called a parameter. And then over here in the example, A, B, C are parameters in y equals ax squared plus bx plus c. Okay, a transformation that increases all the y values, all the y coordinates, or values, same thing, of a relation by the same factor. So that is going to be a vertical stretch. And I'm not going to give you an example yet, because today the idea is that you'll kind of figure this stuff out through some investigation. A transformation that decreases all the y values, you can probably guess if you look at what's left that that is a vertical compression. A quadratic relation of the form y equals blah blah blah, that is vertex form. More on that in a minute. And an example could be y equals 2x plus 1 squared minus 3. And there's like an infinite number of examples of these. That's just one to start. And you don't really know what the 2 or the 1 or the minus 3 do at this point. And that's what today's going to be about. And then that means that the vertical change between consecutive points on a parabola has got to be the step pattern. And again, we'll do an example of that later on, and you can fill in these gaps a little bit later. Okay, so before I get into the investigation, I want to do a quick little recall here of standard form, okay, and factored form. That's what we've done so far. In standard form, we know that this A, if it's negative, it flips upside down. You might remember if A is 2 or 3 or 4, then the parabola gets skinnier and goes up or down faster. If it's negative, it's flipped upside down. The B value doesn't really tell us much. We use that for factoring. And the C value, that's the most important one. That is going to be the y-intercept, or the initial value of the parabola. In factored form, this A and this A are the same. So same rules apply. And the zeros are going to be x equals r and s. All right, so here comes the equation that we'll deal mostly with in this unit. These other two will certainly come up, but the main equation is going to be this. It's going to be vertex form. Now, what I definitely want you to notice so far is this A here, and here, and here, and I'm just going to tell you that that A is the same for all of them. Okay, so if you have a standard form, a factored form, and a vertex form, this A for all of them will be the same. So if in standard form A is -2, when you factor it, remember that -2 comes out front, and you still have it out front. And then vertex form, it'll still be -2. So today is mostly going to be about figuring out what this H and K do. And the hardest part is going to be the fact that this is minus H. So just to give you a little hint, remember, when this is minus R, the 0 is R. So we have to switch the sign. And switching the sign of this here is also going to be very important. Okay, so let's move on. What I have here is some investigations. I'm going to do the first one with you to show you what it looks like. Okay, so in class you would have done this in partners, and we would have sort of gone back and forth, but that doesn't really work here. So what I'm going to do is I'm going to do the first one with you, as I said, to show you what it looks like, and then I want you to do the other ones in Desmos. And I'm just going to post the solutions to this with the lesson, but please don't just copy my answers, because if you do, I don't think you're going to see what's going on. So we will go into Desmos. I guess I better sign in here. So we will go into Desmos. And And what we're going to do is, just like the handout says, we are going to graph y equals x squared. And there it is. Okay, now we're asked to fill in this table of values. So when x is -3, what's y? When x is -2, what's y? -1, what's y? 0, etc. So one way to do that is to click and drag until you get to -3. So -3 is about here, so I click on the curve and I move, and it's 9. So when x is -3, y is going to be 9. And then we go to x is -2. -2 is here, and we can see right here that it's going to be 4. There is a quicker way, and I don't know exactly how to do it, so what I'm going to do is I'm going to kind of figure it out in real time here. I'm going to go add a table, and I'm going to put in the x values as -3, -2, -1, 0, 1, 2, 3. And then for this, what I'm going to do is instead of this, I'm going to type, well, let's see here. If I make this y1, well, that doesn't work. But if I make this y1 and this x1, and then I put in -3, and that doesn't work. So again, like I said, I don't really know how to do this. I'm just kind of trying to figure it out. So insert a table, y equals x squared, so -3, -2, and then if I hit enter, it'll just fill those in once it sees the pattern. And then here, let's say y equals x1 squared. Now that doesn't work. What about y1 equals x1 squared? No. What if I just type x? Yeah, there we go. So if I just type x1 squared, then I get this. But there might be a better way to do this. Because what I'm trying to do is make it so that you can use this same table every single time. So what if instead I say that this is y1, and I say y1 equals x1 squared. So y1, what if I just make this x? Okay, so this should work for everything. Because if I change this equation now to 2x squared, because as you can see in the next, or in one of the examples later on, it is 2x squared. So then you could copy these values. All right, I'm just trying to make this quicker for you. Of course, you could do the click and drag thing every single time, and that would work just fine. But for now, let's do this. And if I click on the points on the curve, or I just look here, 9, 4, 1, 0, 1, 4, 9. So let's go back to the one we were working on. 9, 4, 1, 0, 1, 4, 9. Remember, you can pause and go back to see what I did if you didn't catch it. And then the idea is that you graph in here. I'm not that worried about that, to be honest. In class, though, I think this would have been nice. So 1, 2, 3, 4, 5, 6, 7, 8, 9. What I would like you to notice right now, we have the axis of symmetry here. So all of these points can be flipped over the vertex. So they're exactly the same. And we have that. Ugh. Good enough. Again, the graph I'm not really worried about. It's this other stuff that's important. So what's the vertex? Well, the vertex for this one is right here. So 0, 0. So 0, 0. The direction of opening, if you look at the parabola, it goes up from the vertex. So we say the direction of opening is up. And now we're going to look at the step pattern. So how do you move from point to point starting from the vertex? It doesn't matter if you go left or right. All right, so from the vertex, we'll use this graph. So from the vertex, if I go over 1, that would be to here. I go up to here. Now you might think that's 2, but that's just because I have my minor grid lines turned on. So I'm going to turn those off. And I'm going to make my grid lines for everything 1. And here we go. This is easier to look at. So if you want to know how to do what I just did, just pause it. But you can just look at the numbers. So we go over 1, up 1. So over 1, up 1. And then from here, we go over 1 and we go 1, 2, 3, up 3. And then from here, we go over 1 and we go 1, 2, 3, 4, 5. And my guess is that you can figure out the next one. Over 1, up. And if you guess 7, you're correct. So 1, 3, 5, 7. So since all parabolas have their over steps the same, that's always over 1, we usually refer to these three numbers, 1, 3, 5, or 1, 3, 5, 7, if you want to keep going, as the step pattern. And this is going to become really important when we start graphing these things, and it's going to make it really, really simple. So the step pattern of this basic, standard, default parabola, x squared, is 1, 3, 5. All right, so now you're going to graph parabolas with different equations from the basic parabola, and we're going to compare them to try to figure out what's going on here. So the second one is x squared plus 2. So if we go back here, remember, the way I set this up with x here and y1 here, I can change this to x squared plus 2, and instantly the y values fill in. Okay, so 11, 6, 3, 11, 6, 3, 2, 3, 6, 11. And if we look at the curve, well, the vertex has moved. So the vertex is now 0, 2 in brackets because it's a point. Direction of opening, it still goes up. And now let's check the step pattern. So the step pattern from the vertex is over 1, up 1. And then from this point, over 1, 1, 2, up 3. And then, if you move here, you can find the next point. Over 1, up 1, 2, 3, 4, 5. Okay, so over 1. So the step pattern is unchanged. The direction of opening is unchanged. And all that happened here is that the vertex moved up by 2. And if you look at the equation, you can probably start to figure out what's going on. Okay, so let's try the next one together. X squared minus 3. And what I would love for you to do is to pause the video at this point. Notice I just clicked the home button there, and it put me back. And it'll show the zeros. We're not looking at the zeros right now, but they're there. Okay, so what I would like you to do is to pause and see if you can figure out what happened when we went to x squared minus 3. Okay, so x squared plus 2 moved the whole thing up by 2. What do you think x squared minus 3 is going to do? So please pause and think about that. You might have already answered in your head, but make sure you've thought about it. Okay, so you probably picked up on the fact that when we made x squared negative 3, this is going to be 6, 1, negative 2, 6, 1, negative 2, negative 3 is the vertex. And then you're going to notice that these values get flipped on the other side because it's symmetrical around the vertex because of the axis of symmetry, and that's the vertex there. You might have noticed that in this case, everything just went down by 3. So the new vertex is 0, negative 3. The direction of opening is still going up. And the step pattern is still up 1, 3, 5. And here's the important part. And I'm going to do this one with you sort of live-ish here. What is the effect when a number is added to or subtracted from the equation of the basic parabola? Well, what I can do here is I can change this to plus k, and I can add a slider. I'm going to make the step 1, and now what I'm going to do is I'm just going to change k, and I'm going to watch what the parabola does. And just watch the vertex. So what does changing k do to the vertex? Okay, so let's give it a shot. So when a number is added or subtracted from the equation, the vertex moves up or down by that amount. And you will notice, hopefully, that when we add, it moves up, and when we subtract, it goes down. Okay, so that's k. That's the last value in the equation. Now let's try this one. Now we've got in brackets, and those brackets are very important. So I'm going to erase this whole thing. Go bracket x minus 3 squared. I'm going to erase this slider for k, and we did x minus 3 squared. We've still got our same table here, except for now it's changed. So 0, 1, 2, 3, 4, 5, 6. So I'm going to change that to 0, 1, 2, 3, 4, 5, 6. And be careful hitting enter. Sometimes it gets a little squirrely. So here's our y values. So 9, 4, 1, 9, 4, 1, 0, 1, 4, 9. And if that seems familiar, it's because it's the same y values from here, except for I changed my x values. And if we look at the graph, well, let's do the vertex. The new vertex is 3, 0. It's still going up. And the step pattern, over 1, up 1, 3, it's the same. Up 1, up 3, up 5. Okay, let's do the next one. X plus 4. So x minus 3 moved to the right. So what do you think x plus 4 is going to do? Well, it moves it to the left. Okay, and you'll see our x values are different. So make sure you change those. So -7, -6, -5, -4, -3, -2, -1. And the y values are the same, except for now the thing's been moved to the side. So 9, 4, 1, 0, 1, 4, 9. The new vertex is -4, 0. It still goes up. The step pattern is still the same. And now we have to answer this big question here. What's the effect when a number is added to or subtracted from the x value in brackets? So when we have +4, it moves to the left. And when we had -3, it moved to the right. But remember, this is in the form y equals x minus h squared. This is the most important part of the lesson right here. So when h equals 3, the equation is y equals x minus 3. When h equals -4, the equation is y equals x plus 4 squared. Now I want to relate this to our previous unit. Remember in the brackets, if it was x minus 3, then the 0 was +3. So same idea here. If it's x minus 3, the value of the vertex is +3. And if it's x plus 4, the x value of the vertex is -4. So what I'm going to say here is the parabola is moved left or right. Okay, so, and then there's the examples above. So if h is positive, the parabola, or the vertex of the parabola, same thing, is moved to the right. But the value in brackets is actually negative. And the vice versa works here as well. If h is negative, we would see a positive in here. So you change that sign. And that's something you'll get better at with a little bit of practice. All right. I think I'm just kind of doing this with you, so I'm going to do these next two with you as well. Again, it's not ideal. But circumstances are not ideal. So now we got y equals 2x squared. So I erase this, 2x squared. And by the way, to get the squared, I'm hitting Shift 6 to get the little symbol that looks like this. Oh, you can't see it. When I do that, I get... it's not on here. But it's a little like tent, like a little triangle tent. Kind of like the less than sign or the greater than sign, but with the point going up. Okay, so 2x squared, and then my x values are back to normal. All right, so let's see here. When I do 2x squared, the y values are going to be 18. 8, 2, 0, 2, 8, 18. And if you compare those to the original ones for x squared, we had 9, 4, 1, 0, 1, 4, 9. If you compare these values to these values, what do you see? Well, each value has been doubled or multiplied by 2. Okay, let's check out the vertex. The vertex has not changed. The direction of opening, it's still going up. And let's check the step pattern. Over 1, up 2. And then from there, over 1, up 1, 2, 3, 4, 5, 6. And then from there, well, that's a big jump. Over 1, up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the vertex is the same. It still opens up. It looks like in this case, when I change that value out front, or that A value, the step pattern changes. And you might remember from the first day of 2 units ago, so unit 3, we figured out that this A value out front, if it gets bigger, like 2 or 3 or 4, the parabola goes up faster. So what I'm going to do here is I'm going to graph y equals x squared at the same time. And what you'll see is that our new parabola goes up twice as fast. Each y value from 4 to 8, 1 to 2 has been doubled. And if you double 0, of course, you still get 0. Okay, so let's do the second one. Negative 1 over 4x squared. Negative 1 over 4. And then I hit the right arrow, x squared. Okay, so let's get rid of this. Let's go home. Okay, so I've left y equals x squared here in black. And you're going to notice a couple of things here. So let's fill in the table of values first. So it looks like it's negative 2.25. So the values start to get a little ugly now. Negative 2.25, negative 1, negative 0.25, 0, and then they repeat. Negative 0.25, negative 1, negative 2.25. Okay, so this is a little weird now. You'll notice a couple of things. One, the parabola's upside down. So it opens down now. This is the first time that one of our parabolas has opened down. The vertex is still 0, 0. And to get the step pattern, I'm going to zoom in a bit here and try and figure out what this step pattern is. So this point right here is, the y value is negative 0.25. I'll do this one as well. So that means we go over 1 and down 0.25. Down 0.25. And then we go over 1, and then we're from 0.25 to 1. So it's going down by 0.75. And then from here we go over 1, down 1, and another 0.25. Down 1.25. So it might not be obvious to you what's happening here, but let's compare those values to the original. They were up, and it was 1, 3, and 5. So how do I turn 1 into 0.25? Well, if I do 1 divided by 4, I get 0.25. I wonder, if I do 3 divided by 4, I get 0.75. And if I take 5 and divide it by 4, I get 1.25. Now if you look at our new a value, it's negative 1 over 4. Some of you might realize that negative 1 over 4 is the same as negative 0.25. So if I graph negative 0.25x squared, you're going to see as I turn it off and on here, it's the exact same. So when we have a fraction, we can write it as a decimal, unless it's like 1 over 3 or 7, when the decimal wouldn't be exact. But this works, right? These are both the same. So it looks like our step pattern has been changed. In this case, divided by 4. And in the case of 2x squared, our step pattern was multiplied by 2. So what's the effect when a positive or negative number is multiplied by the equation? So this is our a value. So if the number, I'm going to say a value, is negative, parabola opens down. Also, the normal step pattern, 1, 3, 5, is multiplied by the a value. Okay, so that's sort of the first part of this. And now what we're going to do is we're going to put everything together. Okay, so again, I know I said I wasn't going to do this, but I am, and I keep forgetting to tell you, I would really like if you could graph this and fill everything in before I do, like pause it. So for example, we're going to do the next example, which is 2x minus 3 squared. I think it was plus 1. It is. Now, what I would like you to do is to pause. So there's x squared, and here's our new curve, and it looks very different. And our x values are 0 to 6. So 0, 1, 2, 3, 4, 5, 6. Okay, so that'll put all the points on there for you. So what I would like you to do is pause, fill in all this stuff on your handout, and then unpause to see how you did. So please pause now. All right, so I'm trusting that you paused. I'm sure some people didn't, which is too bad, because if I just tell you everything, I don't know that you'll get it as much as if you think about it yourself. So I'm going to fill this in first. So 19, 9, 3, 1, 3, 9, 19. Now we'll fill in the information. The vertex is 3, 1. It opens up, right? From the vertex it goes up. And the step pattern, let's see here, we go over 1, up 2. Remember the normal step pattern is 1, 3, 5. Over 1, 1, 2, 3, 4, 5, 6. And the next step would be from 9 to 19, so that's up 10. Okay, and then we'll do one more example. Again, I want you to pause it. You can write 1 over 2 as 0.5 if you want. And then it's x plus 1, x minus 3. I'll click home. I'll look at my x values, negative 4 all the way to 2. So negative 4, negative 3, negative 2, negative 1, 0, 1, 2. So here's my, my points. I would really like it now if you would pause, fill these in, and then come back. Okay, so I'm hoping that you paused, and I get 1.5, negative 1, negative 2.5, negative 3, and then negative 2.5, negative 1, 1.5. Okay, so let's fill in the stuff. Again, I'm hoping you did this already. The vertex is negative 1, negative 3. It opens up still, and the reason that it opens up is because the value out front, this a value, is still positive. The step pattern is going to be over 1. I gotta zoom in here. it looks like over 1 up 0.5, up 0.5, and then up a half, 1.5, up 1.5. I probably didn't need to write up if I have the up arrow. And then from there, it goes over 1, up 1, 2.5. And if you remember, that should be 2.5. The original step pattern is 1, 3, 5. So you can see here the steps have been cut in half. Okay? Could you determine the vertex of the quadratic relation without graphing? I think yes. Now let's look at the equation. So x plus 1 and then minus 3. And the vertex is negative 1, negative 3. So the x value is the number in brackets with the sign changed. Okay. And then what's happening to the step pattern? It is being multiplied by a. Exclamation points, because we're really excited about this. All right, here comes the consolidation part to see if you know what's going on. The goal here is that you can fill in this whole table without using Desmos. So to start, let me show you here. The vertex of this is this number, but with the sign change. So positive 2, and the y value is just this, 1. The step pattern is whatever the a value is. And notice if there isn't an a value, it's 1. Okay, so this is normal. So the step pattern is 1, 3, 5. And the direction of opening, if a is positive, it goes up. If a is negative, it goes down. In this case, it's positive. The next one, again, you can pause and do this if you want. I really encourage you to pause and do this. I'm going to fill it in, and it'll just kind of happen instantly soon. So for the next one, x plus 4, so the x value is negative 4, and the y value is 6. The step pattern, my a is negative 1, so instead of going up 1, up 3, up 5, it's going to go down 1, down 3, and down 5. Because the step pattern is negative, because a is negative, it opens down. All right. One more, and then I'm going to ask you to pause. You can pause and try it now if you want. The vertex, I change the number in brackets. It's going to be positive 4, negative 1. Step pattern is going to be 1, 3, 5, and I'm going to multiply by a. So each number gets multiplied by 4. So 4 times 1 is 4. 4 times the next step, which was 3. 4 times 3 is 12. And 4 times 5 is 20. And you can check these in Desmos. The a value is positive, so it opens up. Now please pause and try this, and then unpause to see if you did it correctly. The answers are just going to pop up in about 5 seconds. So please try it first. Pause now. And there they are. All right, now the last part is you're going to write the equation. Remember, you can pause and look at my answers if you missed them there. So they always start with y equals. Now, I need the a value out front here. And if you look at the step patterns, a is negative 1. Sorry, the first step is negative 1. A is negative 1. First step is 4. A is 4. First step is 3. A is 3. First step is negative 2. A is negative 2. So the first step tells us the a values. This is going to be 2, bracket. The vertex is minus 3 for x and minus 3 for y. So this is going to be x. And when I write the value in brackets, remember, just like the zeros, stuff in brackets, like the zeros were, the signs change. So x plus 3 squared minus 3. And that's it. The y value is at the end. The x value is here with the sign changed. And I would really like, if you could pause, try this last one, and then check the answer. So please do that now. Okay, so the last one, the a value is going to be negative 1, or just negative. And then I get x minus 20. I change the sign, squared. Always put the squared, or else it's not a quadratic. It would be linear. And then minus 10. Last thing for today is to deal with some of the language. So describe the transformations that are applied to this graph to get this graph. So first, I'm going to say the parabola, or the vertex, is moved 4 units to the right and 6 units down. And that's because the new vertex is 4, -6, right? And we get that from here. The x value is 4, the y value is -6. And then this is the tricky part. So because my a value is 2, it means it's going to go faster. So I'm going to say the parabola is vertically, now if it goes faster, it's stretched, like it's skinnier. So vertically stretched by a factor of 2. Let me do the next one with you. The parabola vertex is moved 3 units right and 2 units up. And that's because the value in brackets there is, we have +3 in brackets. That means that the new vertex is -3. And then we would also say the parabola is vertically, and in this case, this a value is smaller than 1, right? Half is smaller than 1, so it's vertically compressed, and then we say by a factor of 1/2 or 0.5 if you'd rather write decimals. Same thing. I'm going to do one more and leave the last 2 to you. You know, I'm just going to do them. I encourage you, though, to pause, try these, and then unpause. So please pause now. So for C, the parabola is moved or shifted 1 unit right and 5 units down. So I made a mistake here. I hope you caught my mistake here. This is +3, so the vertex is -3, so this should have been to the left. So I really hope you caught that. If you didn't, mistakes happen. All right, the parabola is vertically compressed by a factor of 3. And you're probably wondering, how do I deal with that negative on the a value? It's vertically compressed by a factor of 3, and it is reflected about the x-axis. So that means that it was flipped upside down. Okay, so this negative, we always say reflected about the x-axis, because if you picture a graph, and if we have a normal parabola like this, and then we make the a value negative, it's going to go upside down. And if you imagine that this x-axis is like a mirror, this and this are reflections, and the reflections about the x-axis. Okay, so last 2. Again, I'm hoping that you try them on your own first. The parabola is shifted 6 units to the right. I do prefer the word shift. If you say moved, it's technically correct. But as we move forward in this unit and into grade 11, you're going to want to say a horizontal shift 6 units right. But for now, I'll talk like this. So the parabola is shifted 6 units right. We don't have anything at the end, so that means it hasn't moved up or down. The a value is -1, so it hasn't been stretched or compressed, but the parabola has been reflected about the x-axis. And the last one, the parabola has been shifted. Well, you can see here, there's nothing in brackets, so it hasn't gone left or right. It's just gone 3 units down. And then we can say the parabola has been vertically, now this number, 0.25, is less than 1, so compressed by a factor of 0.25. And that's it. Okay, that's all the lesson. I know it's a long one. It's the longest one yet, but it's a lot of new stuff, but it's not hard, right? Like I think once you wrap your head around it, it's pretty easy. Here's the homework. Make sure you check your answers in the back, just to make sure you're on the right track. And the homework shouldn't take you very long. I'm hoping like 20 minutes for the homework hopefully is enough. All right, folks, so good luck. Email me if you have any questions, and I will get a help session someday later this week, probably Wednesday or Thursday, based on the feedback I've got. And it'll be around 12 or 1, something like that. Okay, good luck.